All right, guys, section 4.4 is laws of logarithms. We're going to condense and expand. What does it mean if something expands?
Bigger.
It gets bigger. And if you condense it, it gets smaller. It's exactly what we're going to do today. You're going to be given two different types of expressions, either one that's already condensed or one that's already expanded. You're going to do the opposite. So if it's already pulled apart, it's already expanded, we're going to smush it back together. And if it's smushed together, God bless you, to begin with, we're going to, God bless you, pull it apart. Okay? 3 things, if you guys can remember, you're going to be, God bless you, just fine from this lesson. What I want you guys to write this down with me, is multiplication goes with addition. Subtraction goes with division. And coefficients go with exponents. Multiplication and addition are together. Subtraction and division together. Coefficients and exponents together. All right? Very important that you remember those 3 things. Now you've learned everything you need to know. Okay, when I look at this, again, this is in words, so this is a little harder sometimes for us to visualize. But on the left-hand side, this is the condensed part. This is already smushed together. And over here is the expanded part. Do you guys see the difference? Visually, do you see the difference? You see how the left-hand ones are smushed together and the right-hand ones are pulled apart? Mm-hmm. The first law says log base A of A times B equals log base A of A plus log base A of B. Do you notice how A and B here are being multiplied? And what goes with multiplication? Addition. So when you have your log already smushed together and they ask you to pull it apart, if 2 things are being multiplied, they get their own log, and you pull it apart with an addition sign. If it was already pulled apart and you guys were condensing it into 1, you rewrite it with just 1 log, and your addition becomes multiplication. You guys see that? All right, we're going to practice this with numbers and stuff. It's going to make be easier. But look at the next example. What is right here? Division, right? This says log base A of A divided by B. Well, when I pull it apart, division goes with what? Subtraction. So each piece, each term gets its own log, and the division sign becomes a subtraction. What happens with 3? What is C? What does it become? The coefficient. The exponent becomes the coefficient. If you have a coefficient, then it becomes the exponent. Just goes back and forth. So if you can remember those 3 things, addition goes with multiplication, subtraction and division, and coefficients and exponents, you guys will be all right. So now if you look at the examples, we're going to go through a couple here. We're going to do A and B right now. We'll talk about C a little bit. It says evaluate. When you see the word evaluate, what does that mean to do? Solve it. Figure out what the answer is. They're telling you there's an answer here to figure out. So I'm going to say, okay, A. Easiest way to evaluate, to solve, is to write this as 1 single log. Do you see how this is already pulled apart? What's the log base for both of them? 4. And what are you doing to log base 4, 2 and log base 4, 32? You're adding them. So when I smush it together, I'm going to rewrite it as log with my little 4, just 1 time. And what am I doing with 32 and 2? I'm going to multiply 2 times 32. Equals what? We don't know yet, right? We don't know what it equals. Yes, ma'am.
So why wouldn't you just add them to the same base?
Because you don't add. 32 plus 2 is not the same as 32 times 2.
So we're making it smaller.
That's not the same. I understand what you're saying. Like, it's not that log 4 of 2 is not the same as the whole number 2. And log 4 of 32 is not the same as just 32. So you can't combine those two. And that's an actual number. It's just a fraction or a decimal. It's like saying the square root of 3 plus the square root of 2.
What if it was like...
Can you, hold on. Can you say that that's the square root of 5? No, you can't do that, right? Same thing, because that is a representation of a decimal number that you can't just say log base 4 of 2 and 32 is the same thing as log base 4 of 34. Doesn't work like that. Good question. Very good question. You have to condense it first. You got to smush it back together. So here I can rewrite this as log base 4 of what? What's 32 and 2? 64. And I'm evaluating. I don't know what that answer is, but I now can answer that. I told you guys last week, we don't think in logs, we think more exponentially. So rewrite this as an exponent, as an exponential function. What would it look like? 4 to the power of we don't know equals what? 64, right? This comes up, and then this switches spots. So when I evaluate this, 4 to what power gives me 64? Yep, so your answer here is 3. Now, we're going to be solving equations where you have to use your calculator because you're going to be using irrational decimals and stuff like that. But the concept is the same. What are the two things that are inverses of each other? Logs and exponentials. Good. On your calculator, on your button, ln is the inverse of what? E. Good. Got to remember that. Whew. So now let's look at B. Okay, I have B, and I have log base 2 of 80 minus log base 2 of 5. Are you dealing with the same log base? What's the log base here, and what's the log base here? 2. So I can rewrite this. I can smush it together. Log base 2. What happens when we have subtraction? What does subtraction become when we condense? Division. So this is the same as 80 divided by 5. And I don't know what it equals, but we're going to figure it out. So keep going. This becomes log base 2. What's 80 divided by 5? Not like. What is it? 16. Equals, we don't know. But let's think exponentially. How can I rewrite this? What would it become, Zara?
2 to the question mark power equals 16.
Yep, 2 to the, we don't know, equals 16. 2 to what power equals 16? There you go, 4. So what we're going to work on right now, right, that was evaluating. When it says evaluate, you have to find the answer. But what we're going to work on right now is just simply pulling apart and smushing back together. That's what your homework is going to be. Pulling apart and smushing back together. And the more you practice this, the easier it gets, I promise. So this says to expand each expression. I'm not going to tell you what to do. You're going to have to look at it and go, oh, this is already smushed together. Or this is already pulled apart and I have to smush it back together. But notice here, this is what I suggest you guys do. How many log base whatevers do you have? I only see one. It says log base 2. I only see it written one time, right? So that means this is already smushed together. It's multiply. I have one log. I need to pull this apart. So the first thing I do is I say, oh, look, what's going on right here? That's multiplication. What does multiplication become when we pull apart? Addition. Do you have to do this step? Absolutely not. Do I think it's a really good idea? Yes. Now, everything gets its own log. So I'm going to rewrite this as log base 2 of 6. Then what am I going to put? Plus log base 2 of, that's it. That's it. We're not finding out what x equals, nothing like that. All we're doing is either pulling apart, expanding, or smushing back together, which is condensing. Yes, sir.
So it's like the same thing for ln?
Yep. Same thing for ln, because that's just natural log. So let's look over here. All right, we have a couple extra things going on here, but no big deal. The first thing I see is what right here? Okay, good. You see an exponent, but what am I pointing at right here? So it's going to become addition. Good. I think at the beginning, this is really good for you guys to just kind of bring to your attention. So I see an exponent that's going to become a what? Coefficients. Exponents become coefficients. Now, some of you are going to say, I'm going to do everything all in one step.
I think I got the answer. We're trying to check the answers, right?
Okay, hang on. Hold on. That's good. I'm glad. That's really good. So everything's going to get its own log base 5, your x and your y. If you had a number in front, then the number and the x and the y would get its own. You can do everything at one step, but I'm going to do a couple steps. funny. I'm going to say log base 5 of x cubed plus log base 5 of y to the 6th. You guys agree with me? Okay. So the three things I have to worry about are multiplication becomes addition, division becomes subtraction, and exponents become coefficients. Is there a little more simplification I can do here? Yes, this 3 can come out here, and the 6 can come here. So you have 3 log 5 of x plus 6 log 5 of y. Christian, did you get that? You did? Nice. Good job. Look at the next one. Do you see how there's a numerator divided by a denominator? Yes? All right, there's a few things going on in this problem. Before we start expanding, because it's already smushed together, let's identify what's going to go right here between the A and the B. Addition, good. What's going on here with this division? It's going to become subtraction, good. And the other thing I worry about is coefficients become exponents and exponents become coefficients. Is the cube root of C an exponent? Can I write it as an exponent? How can I write the cube root of C as an exponent? This is the same as ln, good, Pablo, AB divided by C to the 1/3 power. Remember, guys, your roots are just fractional exponents. So anytime you see cube root, it's the same as the 1/3 power. Anytime you see square root, it's the same as what? 1/2. What about if I had the 4th root? There you go. So just remember that. If you want to rewrite it, go ahead and rewrite it. But each piece gets its own ln. How do we read a book? Left to right. So that's how we're going to read our equation, from left to right. So I'm going to write ln, natural log of A. What goes in the middle now? What do I write? Plus ln of what? B. Then what? Minus ln of C to the 1/3. Now, some of you already said, well, I just put the 1/3. That's fine. Put the 1/3 in front already. I like to go step by step by step to make sure. Does every single letter have its own ln? Yes? All right, I don't have any random numbers that don't have any ln with it. I have to make sure every single thing in my problem has its own log. What can I do now with this 1/3? It comes out in front. Not in front of everything. It just comes out in front of what it belongs to. Good. Now, you might have a case where your whole entire, I'll leave it there, just your whole entire problem is in a parenthesis with a 1/3 or 1/2 on the outside. Then yes, you'll have one on your homework, but just say it says like log base 6 of ABC over D to the 1/2. Where does that 1/2 go to? Everything. So when you expand this, what you're going to do is bring that 1/2 out in front of the entire thing. And then everything goes behind it. Do you see how here it's only attached to the C? Here it's attached to everything. Yes, sir. Oh, yeah, right here. Thank you. This should be ln of C. Yeah. No, that's good. That's good. That's good. Thank you, sir. All right. Is this awful? No, it's not that bad. It's not that bad. All right, look here. Without me telling you, go ahead and condense. Doesn't this already look like it's pulled apart? Yep, and so we just want to smush it together. So remember, when you smush together, you want to rewrite with one log by itself. And we're going to go through the process the same way that we just did. Instead of identifying multiplication, division, and exponents, we're now going the opposite way. I see addition, so what is that going to become? Multiplication. My coefficients here are going to become what? Exponents. Good. Very good. So you're going to rewrite using one log. This happens to be log base 10, so I'm just going to write log. You can write the little 10 if you want to. Now, me personally, I just take things kind of one step at a time. So I'm just going to move the 3 here, and I'm going to move the 1/2. So I'm going to say log base 3 plus what? X to the what? Or x plus 1 to the 1/2, right? You don't have to write the plus. You can already assume, or whatever. I'll just do it. Right? I rewrote it with log. If you want to go ahead and just say, I already know that that addition's multiplication, you guys could write it like this. You can skip that one step, that's fine. But is this completely simplified? Why not? The 1/2. We need to rewrite it as what? The square root of x plus 1. Does that 1/2 go to the entire problem? No. If it did, it would be way out in front. Guys, you do nothing with this past this. We are not now multiplying. You're not going through and foiling, nothing like that. All we're doing is pulling apart and then smushing back together. That's it. That is it. Let's look at B. There's a lot of stuff going on here. What is this addition going to become? Okay. What is this subtraction going to become? Good. What is 4 going to become? Exponent. What is 1/2 going to become? What is 3 going to become? Okay, good. What is the one log that I'm going to write that goes in the front? Then I don't have to rewrite again. What's going in the front? ln. Good. It's just natural log. No worries. So I'm going to rewrite this as s to the 3rd times t to the 1/2 divided by t squared plus 1 to the 4th power. You guys see, I don't like to use s's and t's, but we'll work with it. Am I completely simplified? What do I have to fix? Yep, the 1/2. We cannot leave fractional exponents. So I have natural log of s to the 3rd square root of t over t squared plus 1 to the 4th power. Now some of you are going to say, is it okay if we multiply that out? No, it's not. Do not FOIL anything out. Just leave it. All right, now we're going to talk about change of base. Most of your calculators do not have the change of base formula programmed into it. You need this information in order to be able to solve your equations later on this week. What I'm going to tell you guys, and write this down, to use the change of base formula in your calculator, you're going to hit the log button of the big number divided by log of the little number. Now, this is the easiest way for me to explain this to you guys. Because when you look at log base 5 of 12, log base 9 of 2, I'm not talking about the numerically bigger and smaller value. I'm talking about visually the numbers that are bigger and smaller. So if I look at this, right? Some of you were coming up to me during your quiz and like, I can't put this in my calculator. Well, we hadn't done that yet, so you were not answering the correct question. But the change of base formula, you're going to get to a point where you have to evaluate that, and your calculators don't do that. Remember, your calculator is in log base 10. So the way that you would evaluate that to get your answer, what is the visually bigger number? 5. So you would, in your calculator, hit log 5 divided by what's the little number? Log 8. Not just 8. You have to hit the word log. But that's what I mean by that. I know that 8 numerically is bigger than 5, but visually, what is bigger? That's the change of base formula. Hit log 5 divided by log 8. Round to 5 decimal places. What do you guys get? 77397. Okay. What about if we did B? This is what you would show me. If you had a problem like this, you had to show me your work. What goes in the numerator? Log 20 divided by what? Log 9. There's not much partial credit I can give you guys here. What's log 20 divided by log 9? 1.36340, 1, something like that. That's it.
What do you do with that one?
That is evaluating log base 9 of 20. So when we go to solve in a couple days, that might be your final answer.
So saying that 9 to the power of that.
Yes.
So it's
Try that in your calculator. Hit 9. Do that. 9 and raise it to the 1.36341. See what you get. It's pretty darn close, right?
Yeah.
So Pablo just said, very good question. Pablo said, because if you rewrote this in exponential form, because we think exponentially, correct? This is the same as log. When I go to exponential, my 9 becomes the big base, and then 1.36341 equals 20. When you do that in your calculator, because all we did was just switch spots, you get like 19.999. It's not going to be exactly perfect because you have to round, but it's pretty darn close. So you're going to be getting answers like that when we solve our equations. So you can plug back in and make sure if you're kind of around the correct answer or not. That's good. Very good thinking, Pablo.